Okay, so this is another video once again on derivatives of inverse trigonometric functions. So we did a pretty straightforward one yesterday, but some of them can get trickier. So let's use this. Let's use the derivative of cosecant, of arccosecant x. So I know for sure that it's equal to negative 1 over x times the square root of x squared minus 1. Not bad. So let's actually prove this. To prove it is quite simple, and it's the same steps as last time, but let's just go over it once again. So for now, ignore that derivative. Let's just focus on arccosecant. We'll set it equal to y. Now we'll multiply it by regular cosecant times arccosecant, times arccosecant times x equal to, multiply by cosecant once again, cosecant of y. Now, as we know, these two are inverse, so they're going to cancel out, which means that we're just left with x. So now we have x is equal to cosecant of y. To make it a little bit cleaner, I like to just write it as cosecant y equal to x. It's the same thing. Now that we have this, here's what we're going to do. We're going to draw a triangle, as always. It's always better to be visual with your stuff. So here's my little triangle. I can't really draw a straight line, but this is our angle y. And we know that cosecant, in general, I'll just write it right here at the top. Cosecant is the opposite of sine. So what is sine? Sine is opposite over hypotenuse, which means that cosecant is hyp over opposite. Right? Beautiful. So now that we have this, we know what our hypotenuse is. Our hypotenuse is x, which means, let's just label it right here. Our hypotenuse is x. Remember, hypotenuse is the longest side of the triangle. And then we know that our opposite of our angle is going to be 1, right? Because if it's only x here, it's like saying x over 1. So this side is 1. Beautiful. So now that we have enough information about this, now we can start taking the derivatives. So let's do it. D by dx of cosecant negative 1. Oh, no, sorry. Once again, we're just ignoring that. Y equal to x, derivative of x. As we know, there is no issue over here because it's with respect to x. So this is equal to 1. But we have an issue right over here because it's with respect to x and there's a y, which means that we must use implicit differentiation, which just means take the derivative of this with no problem, which is negative cosecant y cotangent y. But we have to multiply this by dy over dx, and this is going to be equal to 1. Beautiful. So now that we have this, what we're going to do is now take this, put it under our 1. So now we're left with dy over dx is equal to 1 over negative cosecant y cotangent y. And this is enough information to solve for our derivative. So here's the derivative. What is cosecant? Let's just write this very simply. Cosecant, as we said before, is hyp over opposite. And cotangent, as we said, well, we didn't say it, but we're going to say it now, is the opposite of tan, which tan is opposite over adjacent. So this is going to be adjacent, I'm not sure why it's not writing, adjacent over opposite. Very nice. So now we have enough information. Now let's just continue writing down here. dy by dx is equal to 1 over negative cosecant hype over op. What is our hypotenuse? It's x with respect to y, right? X over 1. So our cosecant value is x. And then we have to multiply this by cotangent, adjacent over hypotenuse. What is adjacent to here? Well, according to Pythagorean theorem, b, not sure why it's not writing, b is equal to the square root of c squared minus a squared. So we have x squared minus 1 times the square root of x squared minus 1. Now would you look at that? This matches up perfectly with what we said up there. So we know for sure that the derivative of arc cosecant x is in fact 1 over negative x times the square root of x squared minus 1. I hope this video was helpful. Remember to try it on your own. That's the best way to learn. And that's it. Thank you.